I have added my Navmesh to the scene, and my character is working with the Navmesh, and the character itself is being driven as a dots entity. This, however, does not give me all the basic elements that I need for a character controller. What I need to do next is add physics to the scene. I'm going to want to add logic to this NPC, and we need the ability to drive that logic. The way in which I'm going to drive the logic is to use physics objects as triggers, and because of this I will need to add physics. Before I start looking at things like triggers, however, I'm just going to add basic physics. I need to get physics working at the same time that I'm getting the Navmesh working, which is not as straightforward as it seems. And to do this, I'm going to test with basic collisions. So we will be adding the physics now, and to make sure that we've got the correct packages, I'll need to go to the package manager. For dots physics, there are actually two packages which we can use. The first of these will be Havoc Physics for Unity. Havoc is one of the most widely used physics engines in games. It is, however, a paid plugin, and I will not be able to use it in the runtime. It is far outside of my budgetary range, so I cannot afford it, and so I will not be using Havoc Physics. The other option is Unity Physics. This is Unity's physics, which is built explicitly for dots. This is also a stateless physics system, which means it will be very efficient for what I want to use it for, which in this case is going to be collision triggers for my AI. I'll possibly also be using it for ragdoll collisions. Since I'm not going to be looking at a large amount of stacked physical operations, this should be more than sufficient. This is already installed, so I do not need to reinstall it, and this means I can begin to work with the physics. I'll begin by updating my Navmesh agent, and this is a Navmesh agent entity which is being created within a subscene. I'll add an object to the scene to test the physics, and this object will be a cube. I'll raise this cube above the ground, and then I'll press play. The cube is now in the scene, but nothing else will happen. To have physics run on the cube, I'll need to convert this into a physics object, which means I'll need to add some components to it. Unity Physics has been set up to work with the traditional game object physics components. By default, the cube will have a box collider added to it. This will give us our collision shape. And to specify that this is a physics object, I'm going to add a rigid body component to it. Nothing will happen within the scene. However, within the game itself, we should see the box is now falling. This means that the box is being spawned as an entity, and this entity is reacting to gravity. I am not particularly happy about this visualization, as I would like to be able to visualize objects within the scene, and not just in the game window. To do this, I'm going to create an entity, and this entity will store global information about my physics. For this, I'll create a subscene, and this will be called Sub Physics Global. This will be used to control our global physics simulation options. This will not be necessary to use the physics, as our physics is already working, but it will give us finer control. I'll now add this to the scene. I'll create an empty game object, and I'll call this Sub Physics Global. I'll add a subscene component to this game object, and here I'll specify my Sub Physics Global subscene. I'll make the scene editable, and I'll remove the camera and I'll remove the lights. I'll add a new empty game object for the terrain, and I'll move this into the subscene. I can then add components to this. The first component which I'm going to add will be an entity component, and this will be a physics component. This is a component for our physics integrator, which is called Physics Step. This will affect the global simulation loop, as this will give us settings which apply to every single physics item. I will not be doing anything with this, but we should have it, and there should only ever be one copy of this within the scene. There is a second component that I want to add to the subscene, which will currently be more important than this, and this is also an entity's physics component, and this is the physics debug display component. The first option that I can activate here will be draw colliders. This should now highlight my cube, and we should be able to see the collider in the viewport. I can also activate draw collider edges. I can then test by pressing play. We should now be able to see the object falling in the scene, and it should be falling through the ground. I do want the box to be able to collide with the terrain, so I'll add a collider to the terrain. To do this, I'll add a physics component to the terrain, and this will be a mesh collider. We should now be able to collide with the terrain, but when we press play, the cube will fall straight through it, and this is because the terrain is not an entity. The physics for the entities will only work on other entities. Since the terrain is fundamentally a game object, the physics for the entities will not interact with this, so we're going to need to turn the terrain into an entity. I have already created a subscene for my terrain geometry, and this is used in my original test scene for the player. If I enter the scene, we'll see that this scene contains my HDA, and since this is using the default settings, it should actually be exactly the same as the terrain in my AI scene. So I should be able to add the geometry terrain to the scene. To do this, I'll create a new game object. I'll call this subterrain, and I'll add a subscene component to this. The subscene can then be set with my terrain subscene. This will add the terrain geometry to my project, which means that we now have two instances of the terrain geometry. I'll disable the original geometry for the moment. We can remove it later. Here we should see that the visualization within the scene does change, and this is because my second terrain already has a collider attached to it, as well as a rigid body object. So if I press play, I should now generate an entity for the terrain as well as for the cube, and the cube should collide with this terrain. And since this is a rigid body, that will cause the terrain to fall. So I can look at the geometry for my terrain. Here we have the rigid body component, and this has two items which are unticked. These are use gravity and is kinematic. As this is the ground, gravity should not move it, so that should be unticked. I will leave is kinematic unchecked as I want objects to collide with this. We should not be animating the ground by other means, but we do not want it to move, so we should turn this into a static object. The cube should now collide with the ground when we run the scene. So our physics is now colliding with the ground, but we do have a slight issue here in that we no longer have the Navmesh. I'll clear out the terrain from the subscene, and I'll move the existing terrain from this project into the scene. And I'll do this because this already has a Navmesh associated with it. This should still have the same collider which I added earlier, so when I press play, the cube should collide with the terrain. So once again, our physics is working, but this terrain does have a Navmesh on it, and the Navmesh is not working. And this is despite the fact that we've added a terrain which does have a correct Navmesh, and we know that this Navmesh works. There are a number of ways to deal with this. The Navmesh agent can be brought into the scene in a number of ways, and it's important to remember that the Navmesh agent does not need to be specifically associated with the geometry itself. The Navmesh itself is not directly used. Instead, the data is stored as part of a Navmesh object. This Navmesh is not actually added to the scene. We only are adding the data to this Navmesh object. Essentially, we do not actually have to have a Navmesh component within the scene. The Navmesh surface component is used to generate our data, but it doesn't actually represent the final data within the scene. So I should be able to load the Navmesh data separately from my entity, and to do this I'll create an empty game object. I'll call this object Navmesh Manager. I'm going to create a new script to run on this game object, and this will be a monobehavior script. I'll call the script Navmesh Manager. This can then be added to the Navmesh Manager game object. I should now be able to edit this script. I want this to be loaded before anything else, so I'll perform this within an await method. I'll be storing our Navmesh data in a variable, and this will need to be exposed within the editor. To do this, I'll have the attribute serialized field. This will be of the type Navmesh data. I'll give this variable the name data. In the awake function, we're then going to work on the Navmesh itself. Now, the Navmesh is something which we do not actually access directly. This is more of a global object that is created by Unity, which we then add information to, than something which we actually create by ourselves. For example, we cannot actually store the Navmesh within a variable. Trying to do this will give us the message that this is a static type. So essentially we cannot instance this, but we can access it and we can set the data on it. So in the awake function, I'll reference the Navmesh, and I'll call the add Navmesh data method on this. And here we'll add our Navmesh data using the data variable. This should be enough to create the Navmeshes within our scene, and we should not actually need anything else in order to make the Navmesh work. So now I can return to Unity, and I should now be able to add my Navmesh data within the script. I will have various versions of the Navmesh data, and these versions have been generated at various times. These Navmesh data files will be stored within the scene in which they were generated, and will generally have similar names to the names of the geometry that they were generated off. If I was to rebake the geometry, I'd get a new piece of geometry, and this would be numbered differently. And because I've generated this within my subscene, this data should now be added to my subscene folder. I can now use this data within my Navmesh Manager. This should now work even if we no longer have the terrain, so I can disable the terrain within the entity before testing this. When I run this, my character is moving. However, when I regenerated this within the subscene, I did not have any of the walls within the subscene, and this means that the Navmesh does not take the walls into account. So in order for this to work, I'll need to move the walls within the subscene. I'll then need to regenerate the Navmesh again. Here I do have some positioning issues which I need to fix, but I should be able to generate the mesh again, and this will take the walls into account. I can add this updated Navmesh to my script, and I can test again. Once again, I could do this without the terrain geometry itself or the Navmesh surface which we're using to generate the Navmesh. This is essentially how we'll get the Navmeshes to run. We can actually add the Navmeshes using entities, although that will be less efficient. This will use a very similar method to what we've used before, and I'll go through this now, although this is not the method which I'm going to use, as we do not need to regenerate the Navmesh data every frame. To do this, I'm going to get another game object, and I'm going to add this as part of my terrain subscene. I'll call this terrain, and this will be the instance of my terrain, and I can move this into my subscene. I'll add a new script to my Navmesh folder, and I'll call this authoring terrain. I'll also need a system script for this, so I'll add a system script, and this will be called system terrain. I can add my authoring script for the terrain to the terrain object which I've just added to the subscene. I can now edit the script. There will be a couple of variables that we'll add to this terrain. The first of these will be a game object, and this will be called terrain. And the second will be our Navmesh data, and I can call this data. I'm then going to add my components to the script. Currently I have a script where I'm adding general game object components. But for this script, I'm going to add this within the script, as I'm probably not going to use this. These are going to be managed components, so they'll be a public class. This will be called GeoTerrain, and it will inherit from the iComponent data interface. I'm going to use this to store my terrain data, and this will be a public game object, and I'll call this terrain. I'll then have a public class for my Navmesh data, and this will be called GeoNavmesh data. This will have a public variable for our Navmesh data, and this variable will be called data. I can now populate my entities, so I'll create an entity, and this will be called entity. I'll define this with the getEntity function. This is going to be a static object, so I'll specify the transform usage flags as none for the moment. I'll add my components to this, and as these are managed components, I'll use the addComponentObject method. I'll add this component to my entity. I'll then specify that this is a game object terrain with new game object terrain. This component will be initialized between curly braces. Here I'll set the terrain variable with authoring.terrain. My variables here should be public. The Navmesh data will be added in the same way, only here we'll add a new game object Navmesh data component. This will be setting the variable data, and this will be set with authoring.data. We can now use these within our system. I'll be updating the system, and I'll be creating an entity component buffer. I'll get my buffer with systemapi.getSingleton. So for this, I'm going to be looking for my begin fixed step simulation entity component buffer system. And here we'll call .singleton. I can then create the buffer using the create command buffer method. And this will be a world unmanaged buffer. I'll specify this with state world unmanaged. I can now loop over my terrain objects to add them to the command buffer. So I'll have a for each loop. I'll then specify two variables, and these will be terrain and data. I will also have an entity variable, as I will want to be able to specify the current entity. I'll get them with systemapi.query. For our terrain, we'll be querying our game object terrain, and for the data, I'm going to query the game object Navmesh data component. I'll specify that entity by using withEntityAccess. I can then create an instance of my game object. I'll store this in the variable game object, and we're going to need to instantiate this. To do this, I'll use the game object class with the instantiate method, and I'll instantiate this with terrain.terrain. I do not want this to duplicate itself, so I'll remove components at the end of the loop. I'll do this with ecb.removeComponent. I'll be removing my game object terrain, and I'll be removing this from the entity. For this, I will not only remove the terrain, I will also remove the Navmesh data. I can then update the data for the Navmesh itself, and I'll do this with navmesh.addNavmeshData, and here I'll get my data with data.data. I can now test this within Unity, and my scene is working. However, this is because I still have the Navmesh Manager within the scene. So I'll deactivate the Navmesh Manager, and this will not work because I have not updated the variables for my script. In the terrain authoring script, I'll need to set two fields. I'll need to add my terrain to this. For the Navmesh data, I'm going to specify the data from the subscene. We should now be instantiating our terrain, and our Navmesh agent should be working with the Navmesh. So now I have my terrain geometry being generated dynamically, which is not something which I really need to do, as I could actually just generate this as an entity. This terrain geometry does not currently have collision, and that will not really work because the terrain is currently being set up as a managed component, and I should actually just set this up as an entity. I actually do not need to instance the terrain here at all, I only really need to set up the Navmesh. But this terrain setup is overkill at the moment as I'm not doing any terrain yet. And setting up that kind of terrain would be part of a much larger terrain system, and what I'm really working on at the moment is characters. For the moment, I'll stick with the Navmesh manager, as that's a reasonably simple way to set this up and it works, and it also cuts down on the number of managed entities which I have. Managed entities are useful, but in the long run, I will eventually want to try and remove them where possible. So I will not get rid of the terrain system at the moment, but I will comment it out. I may use this in the future, but at the moment it is irrelevant, so we do not need any of this functionality yet. So the way this is currently going to work is I'm going to generate my terrain as an entity, and I'll add the Navmesh agent using my Navmesh manager. I will only really need to update this when I get to the point of loading terrains dynamically, or having destructible objects where I need to modify the Navmesh. So this will set up my physics, and my physics will now be working with my managed Navmesh, which will mean that I can now start creating triggers in order to control my NPCs.